Hello everyone. Today we will see a few fundamentals of acoustic. Then we will move towards the types of different transducers for sound. That is conversion from sound to electrical signal and from electrical to sound. That is a popular transmitter. That is nothing but a popular transducer. They are nothing but microphones and loudspeakers. So before that, few fundamentals regarding this acoustics we will see. Now all of you give attention. Our human vocal tract system is normally compared with the public address system. What is public address system? You have a microphone, you have a pre-equalizer, preamplifier, driver amplifier, output amplifier, and speaker. So whatever you speak in microphone, that is going to be amplified and given to the loudspeaker. So your sound can travel to the more distance. Whenever you speak and shout loudly, the limitation of your sound reaching to another end is there. Okay, but if you really want to send your sound at a long distance, okay, then you have to use a public address system so that the output from your mic can be amplified to a certain level with the help of amplifier and given to a loudspeaker, which throw your sound energy from one place to another place at a larger distance. So that is what I'm telling you. Normal vocal tract system, it is analogous to your public address system. So let us say this oral cavity is acting as it is used for resonance control and sound amplification. Okay, actually the source of sound energy generation is a vocal cords. Then uh, this oral cavity is used to resonate control, that is used for resonance control and sound amplification. And finally mouth is nothing but a radiator. So just now I told you a public address system is represented by three different components: mic, amplifier, loudspeaker. Likewise vocal tract, vocal cords. Okay, okay, it is acting as a source of sound energy generation. Then this oral cavity is acting as a resonance control and sound amplification system. And finally your mouth is acting as a source of sound energy radiation. So microphone, amplification, and radiation like loudspeaker. That's why it is compared. Next, that is what I'm telling you, that your public address system, okay, is proportional to your human vocal tract system, or human vocal tract system is proportional to your public address system. So if you use microphone as a transducer, so sound energy, whatever you speak in front of microphone, it is converted into a electrical signal of approximately frequency 20 hertz to 20 kilohertz if the musical instruments are there along with your home main speech or woman speech. So this is a general indication of analog electrical signal. Okay, analog electrical audio signal. So different patterns I have taken over here. This pattern, if you take analog signal and digitize it, then it will look like this. Now intensity of various types of sounds, they are measured with the help of different units you are aware of in physics and in different subject. As an engineer you have already studied it. So what are the different popular units or intensity of various types of sounds, how it is represented? See this. The first is pressures in pascals or newton per meter square. This is the first. Second one, pressure can be measured in a microbar. Then intensity of sound can be measured in watts per meter square. And third, intensity can be measured in decibels. So most popular sound intensity measurement unit is in decibel. So different types of sounds are there. Then I have taken this figure from R.G. Gupta's book. So different types of sounds and different types of uh, um, units and their values are represented in this table. Now we will simplify this type of sound and the intensity in decibel. If it is a threshold of hearing, then it is 0 decibel. A rustle of leaves gives you 10 decibel. Whispering gives you 20 decibel. Average residence 40 decibel. Soft note of a violin at a 3 meters from microphone or that dB meter is 44 decibel. Ordinary conversation 50 decibel. Sound of an average automobile 60 decibel. Normal speech 74 decibel. Heavy traffic 80 decibel. Thunder 100 decibel. Loud rock and roll band in a small hall gives you 120 decibel, and threshold of pain will give you 130 decibel. So above 130 decibel, you will realize a threshold of pain. Okay, you will realize the pain. So normally this DJ system, which we normally call, okay, and we listen, this DJ system crosses sometimes this 130 decibel, and threshold of pain immediately realized by a person. Now, different types of units, just now I told you, Pascal, decibels, and all these things. One more unit is there called as phone and zone unit. Phone is used to compare the loudness level of different frequencies. So threshold of pain at a loudness level is 130 phones, let us say, while another unit zone is used to determine the increase in loudness. For example, sensation produced by 1000 hertz sound of 40 decibel is equal to 40 phones is equal to 1 zone. Please keep this in your mind. 40 decibel is equal to 40 phones is equal to 1 zone. So phone and zone, these are also different types of units which are used for this sound related measurement. Okay, now one more effect is there called as timbre effect. So whenever you speak, okay, let us say a main speech is there, all of you give attention. Let us say whenever I am saying, let us say this percussion of instrument of drum, whenever you play the drum, fundamental frequency range is 90 hertz to 150 hertz. But if you go for overall frequency including harmonics, not harmonics, you call it as uh, overtones, then it goes up to 300 hertz. If you go for string instrument like violin, fundamental frequency is this, and if you consider the overtones, it goes from 180 to 15 kilohertz. Flute, only fundamental frequency is this. If you consider overtone, it reaches up to 15 kilohertz. If you play trumpet, fundamental frequency is this, and if you consider overtones, it goes up to 9 kilohertz. Pipe organ, if you play, this is the fundamental frequency, and along with harmonics, you see it reaching up to 20 kilohertz. Please keep this in your mind. So pipe organ gives you the maximum frequency and their related overtones. So it covers almost audio frequency 20 hertz to 20 kilohertz. Though frequency starts from 16, you cannot listen. Here the audible range is 20 hertz to 20 kilohertz. That's why maximum 20 kilohertz can be achieved with this pipe organ. Then harmonium, this is the fundamental range, and this is what harmonics goes up to 16 kilohertz. Then main speech and women speech, it is very important because in our laboratory, whenever we take with the reading with the microphones, normally we deal with main speech and women speech. So if you consider main speech, this is the fundamental frequency and overtone is 110 to 8 kilohertz. If it is a woman's speech, then it is 220 to 10 kilohertz. And if musical instruments like pipe organ and all these things are being played at a back end, then it reaches, normally you can call it as 20 hertz to 20 kilohertz. So please keep this in your mind. So what is timbre effect? I told you fundamental frequency, they are mixed up along with overtones. So this quality of sound is called as timbre effect. This is called as timbre effect. So two things we have seen now, the different units, Pascal or Newton per meter square, then pressure in microbar, watts per meter square, then decibel. So decibel is the more popular. So different types of sounds and their decibel. Intensity in decibel is mentioned over here. And we came to know that 130 decibel is a threshold of pain. So normally DJ system and all these things, they operate near this 130 decibel. And thereafter we saw a phone and zone unit. So normally average residence is 40 decibel. So 40 decibel is equal to 40 phones is equal to 1 zone. So this calculation we have seen, and timbre effect, that fundamental frequency along with harmonics, they are available. So your range is exceeding from 20 hertz to 20 kilohertz. So if it is specifically main speech, Normally you take the readings and you write 110 to 8 kilohertz. Women's pitch 220 to 10 kilohertz. And if women's pitch, men's pitch, they are singing along with musical instruments, then definitely you uh, come across 20 hertz to 20 kilohertz signal frequency on your digital storage oscilloscope. Now we will see different types of microphones. Okay, different types of microphones are there. One is ribbon microphone, another is moving coil microphone, third is condenser microphone, fourth is crystal microphone, and fifth is carbon type of microphone. So these five types of microphone we will try to cover in today's session. So before that, okay, the directivity of a microphone, okay, is defined as E upon E0, okay, where E is the actual output in the direction of maximum, okay, this, and E0 when it is considered to be as a omnidirectional. So these 3 dB points or half power points you can calculate. So different types of directivity patterns are supported. Before that, I would like to tell you, this is what the frequency in hertz and this is what the output from the different microphone. So please try to understand. Ribbon microphone, okay, will give you the frequency response like this, but the lowest output. Then second is moving coil. The output resulting from this moving coil is greater than ribbon. Okay. Then if you consider condenser microphone, the maximum, the best frequency response is possible with the help of condenser microphone. Okay. But the output is less than this carbon. So if you want more output, then you go for crystal type of microphone or carbon type of microphone. Carbon type of microphone gives you maximum output compared to all other microphone. But what is the problem with this carbon microphone? The frequency response is limited compared to others. That's why the best frequency response is achieved with the help of condenser microphone. That's why for calibrating sound equipments and sound related meters, this condenser microphone is used. And for PSTN network, you want the maximum output. For speech frequency, the frequency response is not important, that much important. Whenever you are talking or using this PSTN network, then normally this carbon type of microphone is used for that purpose. Okay, so three types of directivity patterns are there. One is omnidirectional. So whenever you speak into this mic, okay, and from all the direction it is going to capture the sound. Then bidirectional, okay, when actor and actress, or let us say a shooting is going on, when they are talking, okay, front to front, then such type of microphones are required. Bidirectional, okay, or figure of eight. Whenever you combine this omnidirectional and bidirectional microphone in series in one case, then it will result in cardiac or heart shaped type of microphone. So the application of different types of directivity pattern in different areas are there. Every pattern has its own advantage and disadvantage. So moving coil type of microphone will result in omnidirectional type of directivity, whereas ribbon type of microphone will give you figure of eight pattern. And if you combine this moving coil of microphone along with the ribbon type of microphone in a simple case in series, then this heart shape or cardioid shape directivity pattern is going to be resulted because of phase addition and cancellation of sound energy. Okay, so let us start with um, moving coil type of microphone. So what is microphone? Microphone is a transducer which converts sound energy into electrical one. So how it works? It is very simple. So this is what the protective cover, and this is a diaphragm, and diaphragm is attached to a voice coil and which is placed in a permanent magnetic field. So this is called as moving coil type of microphone. Moving coil. Why it is called as moving coil? The diaphragm which is attached to this coil. So whenever you speak in this front direction, this coil is moving in this permanent magnetic field. That's why it is called as moving coil microphone. So what is the um, principle of operation? It works on the principle of Faraday's laws of electromagnetic induction. Whenever a moving conductor placed in a permanent magnetic field, EMF get induced, and that induced EMF from this voice coil is collected, amplified, and then it is given to the different processing circuitry. So mic is used to convert sound information into electrical one. So this is what the principle of operation of this moving coil type of microphone. So in public address system, broadcast studios, such type of moving coil type of um, microphones are used. Okay, so this is working um, on the principle of Faraday's of electromagnetic induction. So the induced EMF because of this air pressure, because of this movement of coil, is given by this E, that is BLV volts. B is the magnetic flux intensity, that is B. Then L is the length of coil, and V is nothing but the voltage. Okay, V is nothing but a velocity. V is nothing but a velocity with which this voice coil is moving. So E is equal to BLV volts. Now, second type of microphone, which also works on the same principle of Faraday's law of, laws of electromagnetic induction. So the construction is very simple. A thin, okay, a thin uh, paper is taken on which the coil is wound, so it becomes a foil. So thin foil. So whenever you talk in front, okay, it is placed in this electromagnetic field from the front side and back side. As I told you, two-person can talk, and for figure of eight pattern is normally achieved in such type of microphone. So this is called as ribbon type of microphone. So this ribbon type of microphone, how it works? Whenever you talk, this foil, that is a plastic material over which this coil is bound, is moving due to your sound pressure. So whenever you talk, this moving conductor placed in a magnetic field, EMF get induced, and this induced EMF is collected from this coil, is proportional to your sound energy. Now, one more thing is there in this ribbon type of microphone, that the signal which is collected from this foil is very less. That's why built-in matching transformer is required. Thereafter, amplification is done. So this such type of ribbon type of microphone gives you bidirectional pattern, and built-in matching transformer is required, because you cannot connect the output of this microphone directly to the amplifier input, because amplifier input is in kilo ohm, whereas this coil which is wound, okay, on this plastic, that is foil, few turns are there, it is in ohm. So ohm impedance cannot match with kilo ohm impedance of amplifier. That's why you need to um, use this built-in matching transformer, and finally it results in bidirectional pattern. Okay, so this is known as a ribbon type of microphone, and various applications like orchestras and different where front and two persons, they are standing in front of each other and they want to have a conversation, there such type of ribbon microphone is used. Now the first which we saw is also working on the principle of Faraday's laws of electromagnetic induction, that is coil, moving coil placed in permanent magnetic field, EMF get induced, and induced EMF is nothing but proportional to your sound energy. And the ribbon type of microphone is also working on the same Faraday's laws of electromagnetic induction, that a moving coil because of sound pressure, moving coil because of sound pressure is moving in this permanent magnetic field. So EMF get induced, and induced EMF is proportional to your sound energy. One more thing I told you, it results in bidirectional pattern or figure of eight pattern, and built-in matching transformer is required, because output impedance of this mic is in ohm, and input impedance of amplifier which you are going to connect to amplify the signal is in kilo ohm. So ohm to kilo ohm, such type of impedance mismatching will be there, and maximum power transfer will not be there. So to amplify the signal with proper bandwidth and proper amplitude output, you have to have um, built-in matching transformer, which is used for impedance matching. So if you use moving coil and this ribbon type of microphone in series, because of addition and cancellation of phases of sound energy, it results in heart shape type of heart shape type of directivity pattern. So such type of combination, that is moving coil and ribbon type of microphone, If you use in series in one case, it will result in cardioid or heart shape of directivity pattern. So normally it is used in orchestras and court scenes. So such type of microphones are used there. Okay. Now the next is crystal microphone. So crystal microphone, it's very simple. This is what the diaphragm attached to a crystal material. So crystal material like quartz, rochelle salt, tourmaline, okay, which works on the principle of piezoelectric effect. So what is piezoelectric effect? There are two different definitions. Piezoelectric effect: if mechanical pressure is applied on this piezoelectric material, then electrical signals are available. And if you give electrical signal to this piezoelectric meter to separate axis, then a mechanical vibrations are available. So basically it is a three axis theory. So it is represented like this: X, Y and Z. If you apply electrical signal on X and Y, mechanical vibrations are available on Z axis. Please keep this in your mind. And if the mechanical vibrations are applied on the Z axis of that piezoelectric material, equivalent electrical signal is generated on X and Y axis. Accordingly, these wires are connected to X and Y axis. So whenever you speak in this front direction, okay, the diaphragm is attached on a Z axis of this piezoelectric material. So according to law, whenever you speak, okay, whenever you speak, the sound energy is coming from the front direction. Whenever sound energy is applied, this is applied to Z direction. So mechanical vibrations are applied on Z direction, because of which piezoelectric effect takes into because of this piezoelectric effect on X and Y axis, equivalent audio signal is generated, and finally it is amplified. So home recording, amateur recording, mobile communication, such type of um, crystal microphones are used. Then next is condenser microphone. So condenser microphone construction is very simple. Okay, this is fixed plate, and this is fixed plate, and this is movable plate, in which the dielectric material is kept with a specific permittivity. So C is given by A epsilon divided by D. Okay, A epsilon divided by D, where epsilon is nothing but epsilon 0 into epsilon r. So epsilon 0 is absolute permittivity, and epsilon r is nothing but a relative permittivity. So try to understand. So whenever you talk in this front direction, this is what the diaphragm, metal diaphragm. So whenever you speak, this diaphragm is connected to moving plate. So because of this sound pressure, this plate is moving, and between fixed plate and moving plate, you have a dielectric material. So because of your sound pressure, the capacitance value between this fixed plate and movable plate is going to change, and this capacitance is changing, then V is equal to Q upon C. The voltage across that two plate is going to be changed, and that change in voltage is directly proportional to the sound energy. Please keep this in your mind. That's why V is equal to Q upon C. This formula is written over here. So what is the principle of operation? It works on the principle of operation of capacitance. So whenever you speak, the diaphragm is attached. This diaphragm is attached to a moving plate. Between moving plate and a fixed plate, this dielectric material is there, and this equation is given by C is equal to epsilon by D. So D is the distance between these two plates, and A is the area of plate, and epsilon is the permittivity of this dielectric material used between moving plate and fixed plate. Okay, now this condenser type of microphone, okay, is required a battery for the operation. So whenever you go in a market and purchase a microphone with a battery, I'm not talking about a wireless microphone, where for FM transmission you require battery. For the operation of microphone, I'm talking about the DC voltage is required, because to form the capacitance and change in voltage, you have to have a DC voltage applied to that. Otherwise, the output voltage coming from these two wires will not be proportional to sound. So DC battery is must as far as this carbon microphone is, this condenser microphone is concerned. Now the last type of microphone is nothing but this carbon microphone. So again, the construction, if you see a fixed plate, okay, this fixed plate, moving plate, and between fixed plate and moving plate, you have a carbon granule. Please keep this in your mind. Carbon granules are kept between a variable varying or this moving plate and fixed plate, and this front side is nothing but a diaphragm, and diaphragm is connected to this moving plate. So whenever you speak from this front direction, because of um, sound energy, because of sound pressure, compression and rarefaction of the air, it is going to fall on this diaphragm. This diaphragm is connected to the moving uh, plate, and between moving plate and fixed plate you have carbon granule. So what is happening? Because of sound pressure, because of sound pressure, okay, let us say sound compression is there. So what is happening? The contact, it is going to be pressed, so contact area of this carbon granules is going to increase. If contact area increases, R is equal to rho L by A. Resistance of those carbon granule is going to be decreased. If resistance increases, if resistance decreases, current increases. Now you second another possibility. If there is a sound compression and this is so sound compression in one direction, then sound compression in another direction. Okay, so if it is in another direction, then the contact area between this moving plate and this fixed plate is going to reduce, so resistance increases, and R is equal to rho L by A, and R is equal to V upon I, and based on that, if resistance of that carbon granule increases, then the current flowing will be decreased. So current increasing and current decreasing will give you the potential difference, and that potential difference is nothing but proportional to your sound energy. One more thing, this carbon type of microphone also needs a built-in battery. So if you go in market and if you purchase a microphone, and if the battery is needed, I'm not talking about wireless microphone again, so if the battery is needed, then definitely you consider it must be a carbon microphone, or it must be a condenser microphone. So built-in transformer is required for a ribbon type of microphone, then battery is required for condenser, um, condenser and carbon microphone. So a different type